recording now. Okay. So, how will you monitor your health? So, whoever is crossing 40, 45, maybe your parents or your grandfather, so they will be tracking their health, right? How they will be monitoring? So, how they will be monitoring their health? You tell me. So, anyone have their grandparents with you? Huh?
Yes, sir.
Okay.
Yes, sir.
Okay. How they are monitoring their health?
They check up their regular body samples, that
Uh,
blood reports,
what is their
and
frequency of monitoring?
during 3 months to 6 months.
3 months once or 6 months once they will be monitoring, right?
Yes, sir.
Okay. Okay. Whenever there is something critical, okay, you will be monitoring it. Okay. So that is a personal thing, and I recommend everyone whoever crosses 25 or 30. So everyone should be doing at least yearly once medical checkup. Okay. And you will have something diseases where only blood test will let you know. Okay, like kidney malfunction, it will tell you only at the last stage. Kidney is such a organ, like it will not give up until the last minute. Okay, when it is completely damaged, then it will start giving the symptoms. Until then, it will be telling, see, I am okay, I am fine. Okay, only if you are monitoring, then you will understand how much the kidney is functioning. Okay, that is with respect to your health and organs. Okay, so let's say in our infrastructure, if you are not monitoring, you will not know what is going wrong and what is being performed very well and who is underperforming. Okay, so you need to be checking all the infrastructure. Okay, so you will have a monitoring tool in every organization. If you are not monitoring, means you are not following any standards. Okay, that is why it is very critical to monitor the health and services. So let's say you have a lot of servers. I I am having, let's say I have 400 MySQL servers. Okay, I have Windows 8000 servers. Okay, Linux 12,000 servers. There are a lot of network and endpoints. I don't even remember that. Okay, so I have n number of applications. Let's say I have 40,000 applications. So what is working and what is not working? How I will know? Okay, so I will not know individually if I want to log in. Even if I keep 1,000 people to monitor, still that will not be an effective. Okay, so what I will do, I will be monitoring every server and I will see every parameter I will be checking. So let's say in the health, for a human being, with respect to health, just now you told, right? So we will be monitoring the health for 3 months once, 6 months once, yearly ones, like that. Okay. So here what you will do, like I have all these servers. Okay. So these are the phases. Okay. Let me, I will come back later here. Okay. So I will go in a generic term. Okay. I have a supporting document. So this, today I will share this version 11. Okay. See, in generic terms, okay, I will take this one. Okay. This is generic, that's why I have not kept it. Uh, so you will be collecting all your data sources. Okay. Where is your data lying? Okay. So my data source is my servers. I have physical servers and virtual servers also. Okay. Physical and virtual. Okay. So this is where I am collecting the data here. Okay. So then I have containers here. Okay. So I have lot of containers, whether it is Docker or some other container engine, Podman or anything you can be running. Okay. Docker, Kubernetes, any services, I will be monitoring that also. This is my data source. Okay. So few of the servers are running in my cloud. Okay. 10% are running in cloud. Okay. So I have databases. Okay. That are also running. Okay. I need to monitor that. I have devices and applications. This is all my data sources. Okay. So I have to monitor this. If I am not monitoring, then I will be in big trouble. Let's say this is your um, blood test. Okay. Blood test, and then you are doing some ECG. Okay. And then you are doing, let's say, urine test. Okay. And then you are doing a treadmill test. Okay. So there are lot of parameters that you are checking in. Now you are doing an X-ray also. X-ray is not required. So you are just ensure that everything is working fine. Okay. These are all your data sources. Okay. So you will be collecting this. This is your data collection. Okay. This guy is a sample collection who is coming and taking the blood, or whatever you want to check that parameters, you are collecting that details. Okay. So this guy will be collecting. Okay. So we call this as agent or exporters. Okay. Let's say whether you are giving it or that person is collecting. Okay. So let's say this is pull and push. Okay. Let me check if I am getting this recorded properly. Yeah, this is being done correctly. Okay. Okay. So now either you are doing it with pull or push. Okay. Just an example, like you are going to the diagnostic center or the person is coming and taking that. Okay. This is your data collection. Okay. So you are collecting all the data. Okay. After that you are storing it in something, in somewhere, so that you can process that for later. Okay. This is where your Prometheus will come. Okay. So you will be collecting all this information in one database. Okay. Or in a storage. So you have multiple technologies or multiple tools. Okay. So you will correlate with the cloud also. Okay. Once we are done with that, then we will come back to the cloud, AWS cloud monitor. We will see that. We will see the health monitoring, all that. Once we are done with this, we will come back to the cloud. Okay. So now you collected all this. Okay. So you collected with Prometheus. Okay. Now you want to do analysis here. Okay. Analysis and visualization. the problem with Prometheus is, okay, so I will just collect, I cannot see. Okay. When I was a kid, I had a story like one guy is, there will be two friends. Okay. One is handicapped. Okay. The other one will be blind. Maybe you would also have heard it, this story. Okay. This guy will not have legs. This guy will be handicapped. This guy will not have legs, and one guy will be blind. Okay. Blind guy will have legs. Okay. Handicapped will not. This handicapped guy will be having will not have legs here. Blind guy will be walking. Okay. Handicapped guy will be telling where to go. Okay. These two combine and they will be going anywhere. Okay. So one guy, if he leaves, blind guy, if he leaves the handicapped guy, he cannot see. Okay. So if he is discarding the blind guy, he cannot walk. Okay. This is the combination that we have with Prometheus and Grafana. Okay. So this guy will just collect the data. Okay. He is having the legs here. He cannot see. You tell me, I will collect all that information. This guy will see, but he will not have legs. Okay. So Grafana, you will integrate Prometheus, it will collect the metrics here. Okay. Whatever it collects, it will visualize it in the dashboards, and it will do analytics. Okay. So this is the two combination of Prometheus and Grafana. If you, I will just open up here the document. Okay. If you see in the document version here, you will see that you have monitoring Prometheus and Grafana. Okay. So one, it will be collecting the data. Okay. One, it will be giving the alerts here, visualization. You see this Prometheus. Here you will be seeing the Grafana here. Okay. And now you have something called alerting system. Okay. So this you collected it. Okay. So you collected and you are doing the visualization. Okay. I want something goes wrong. I need to do some alerting here. I need to do some, someone should ring the bell. Okay. So you have motor sensors, right? In water tanks, you will have motor sensors where it will be automatically turning on and turning off based on that sensors. Like if the tank is full, it will be automatically shut. So this is how the alerting engine will be. Okay. So if I am getting something alert, okay, then what I am going to do, I will be alerting to wherever I want to send the message here. Okay. I will alert it based on the rules. Let's say if I am getting ping drops for 5 or 6 consecutive times. Okay. So you just alert me. Okay. So where you want me to alert? Okay. So you alert it to my email, or you send it to my SMS or Slack, or mostly it will be created a ticket here, ITSM and ticketing. Okay. So if something goes wrong, I am going to create a ticket like the server has gone down and the network of the server is down. Okay. This is where your ticketing system will come. This is where your Jira or ServiceNow will come into picture here. Okay. So the teams will be monitoring here. They will be logging in and they will be checking their emails. From this ticketing tool, if any ticket comes here, then you will get an email here. Okay. So that email you will be monitoring here. Okay. This is where the support team will be monitoring their queues. Queue is like you are into one team here. Let's say you are a Wintel team, okay, or else you are into Linux team, or database team, or a cloud team, or development team, or a DevOps team. Okay. So what is the issue? Based on that, it will route the ticket to the respective team. Okay. So database is hanging. Okay. There are a lot of errors on the database. Database is not connecting. Then it will go to the database team. Okay. So if there is no connectivity to the cloud, okay, it will go to the cloud team. Okay, or a DevOps team. If there is a DevOps team which will be handling this, then it will go. Let's say this is all handled by DevOps team. Okay, then it will go to the direct DevOps team. Or else if it is any enterprise support, then you will have multiple teams here like this, where each and every team will be separated with their roles, designated roles. If it is small organization, then everything will go to the DevOps team here. Okay. This is how your ticket flow will happen. This is where your work starts. Okay. So in operations, okay, mostly you will have in DevOps, it will be like in support project, if you are working, then it will be 95% your operations, and 5% will be development. Okay. So in the operations, you will be monitoring your queues, what is happening here. So if you are not getting tickets, okay, you are not getting alerts, means you will stay calm and quiet. Okay. You will be relaxing. If something you are coming, if the tickets are coming, then you will work based on the ticket. Okay. Let's say the server is not logging in. Okay. Password expire. Then you will check, okay, what is the issue, then you will reset the password. Okay. So now we'll see what are the benefits, all that. So you will be proactively doing it. Okay. This is not a reactive. This is all proactive. The monitoring, whatever you do, it is proactive. You are not reacting to anything. Okay. So this is already pulling all the data, and you are detecting the problems here. Before even it occurs, you are just getting ready here. Okay. And you will be faster in responding there. Okay. If something goes wrong, you will immediately respond to that particular issue or problem. Then you will have a better visibility of your entire infrastructure. And then you will be taking the data driven decision. Okay. This is where AI will also come in picture. Okay. Let's say I don't want to give it to human being. Okay. So I am getting it like every 1 week. Okay. For 1 week I get 90% of disk full in web servers. Okay. So I am getting this pattern. Okay. So I get this. Okay. So on web servers, what I will do, I will create a script. I will tell AI, okay, on Friday, what you do, you say, delete /temp directory, you flush all this temp directory. Okay. Every Friday it will delete all that files. So now if I am doing this, then I can reduce 1 FTE resource. Means I am saving one human being timing here. Okay. So I don't have to pay for one guy. Okay. So this is where your AI will come in and it will help you. Okay. This will be manual task. Now it will be automatically doing it. Okay. So if I see any patterns here, continuous patterns, I will take it to the AI to do that job. So you don't have to do it. Okay. So now you can tell, okay, now if AI is doing, then our job is in threat. That's not a statement. That is not a correct statement. It is helping you. Okay. So it is helping you to take a better decision. Okay. So all that data driven decisions, we will be giving it to AI what to do. Okay. So if there are any issues, sorry, then we will alter that particular decision here. Okay. So then what you are going to monitor here? Okay. What is the performance matrix that you are going to monitor here? Okay. So how much CPU you are monitoring? What is the memory, disk, network, etc. Okay. So let's say my server is utilizing for 5 minutes. Okay. 90% it is using. Okay. So now what you do? Okay, you will increase this threshold. Okay. So I need this 3 instance, like 1, 2 and 3. Okay, it should continuously come for me within 1 hour. Okay, I will wait for 1 hour. Okay, if I am getting this 90% for continuous 5 minutes, not like 1 minute. Okay, it is 90%. Okay, then for 2 minutes it is 70%. So that is not an issue. So it should come for me like 5 minutes. 5 minutes continuously 90%. And then in second instance also it should come like 5 minutes. Then you need to give me a ticket like, okay, I will look into this. Okay. So why there is a CPU spike, I will see into this, I will troubleshoot it. Okay. Then my memory also same. Okay. If my memory is 90% utilized, whatever I have assigned, so I will look into that, why there is a 90% memory. Then the disk space. Okay. If more than 80%, okay, you just alert me the server, which server you are getting. So is it the particular server or is it a database where I am getting this disk utilization. Okay. Then network. Okay. So if there is a network utilization, high network utilization, okay, or there are network logins, okay, happening, okay, lot of denial requests are coming. Okay, on the firewall end, I am getting lot of access denied. Okay, I am getting lot of logs. Okay, then you create a ticket. Okay, I will tell. Okay, within 1 minute, I should get 5 to 6 logs of the denial. Then only you create a ticket, or else you don't create. Or else I will tell. Okay, in 10 minutes, I should get 10 denial access, or in 1 hour I should get at least 20 denial of logins. Then you create a ticket here. Okay, this is monitoring and availability also. Okay, so you check the server every 5 seconds once. Okay, I have 4,000 servers. Okay, so 4,000 servers I have. Okay, so these are my VMs, all that. Okay, you check every 5 seconds once. Okay, you just check. Okay, one more time you go and check. This is first time, then second time, third time. Okay, this is not responding. Okay, then you alert it, the server is down now. Okay, you create a ticket, let the support team will work and they will see why the server is not responding. They will log in and check why it is not responding. Whether someone has disabled the NIC card, or it went out of network, or someone changed the IP address, all that, let this team will check this. Okay, so you are checking the availability and uptime of the server. And health check. Okay, whether all the services are running fine. whether the CPU is fine, okay, memory is fine, network is okay, disk is okay. So all three parameters I want to see. If these are okay, then the health check is good. Okay, these are not okay, then the health is not good here. Okay, then you have event and logs here. Okay, so if I will tell, okay, if these events are happening inside the server, you just alert me. Okay, based on the event also I want to generate the ticket here. So in Windows you will get lot of alerts. Okay, every one second, every 1 second, so you might get 10 or 5 logs inside your Windows server. Okay, that you will be checking that. Okay, your event logs, or you can tell even the security also. Okay, so that is how you will be monitoring it. Okay, so these are all your technical monitors. Okay, now you have something called business metrics here. Okay, where there is a business activity happening. Do we have any transaction happened here? Okay, or is there any revenue coming in, or any users are signing up? So all these also we need to monitor this. This is the business requirement. This is the technical requirement. Okay, these are all some alert rules here. Okay, so why it is happening, all that, based on that requirement you will be creating that particular alerts. That is your monitoring system. Okay, so now we will see it. Now we have something called observability. Okay, so this is monitoring. Okay, observability is like you will be observing in every aspect. So you will be checking on the metrics. Okay, what is happening, then you will see the logs, what happened. Okay, then you will check how did it happen, how did that request flow. Okay, these are all make it as a observability engineer. Okay, so this is where Google started this job profile. Earlier we didn't had site reliability engineer, SRE. Okay, Google started this role. So you see everything of my infrastructure. So you don't monitor it, you check every aspect of it and you report me. Okay, these are the key pillars of observability. Observability is little deep. Monitoring is you will be just checking the health check. Okay, so observability you will go deeper. Okay, let's say one guy came into class. Okay, monitoring and observability, I am giving you an example of it. Okay, I will take this to our okay. So one guy came to the class here. Okay, so monitoring is okay. I will just see, okay, whether he is present or not in the class. That's it. Or if I want to check further, okay, if I want to check further, I will see if he is logged in or physically present. So that's it, the monitoring. Okay. So observability is I will see, okay, what is he wearing, what his attire is, what is his dress, how his shoes are, okay, um, how he looks like. Okay, he is looking tidy. Okay, or he just woke up and have come. Okay, so what is his belt? Okay, so does he done the proper ironing of his clothes? So everything I am just observing it. Okay, I am not only monitoring him. Okay, so monitoring I know. Okay, whether he came or not, that's fine. Okay, so observability I am checking on every aspect of it. So that is the difference between your monitoring and observability. Okay. So in the observability you will be doing the metrics here, then logs, and then traces here. Whereas in monitoring you will be just checking the metrics here, that's it. You will not be seeing the logs or you will not see the traces. So you just take the parameters and you will just do the alerting. Okay. So if this goes wrong, I have to generate the ticket, that's it. If something goes wrong, I will going to do some alerting. Okay, this is what I have to supposed to do in monitoring. That's for the observability here. Okay, so we will see from the document only, supporting document. Okay. So this is at the observability end. Okay. So monitoring it will be different. Observability you will be looking into the deeper aspect here. Okay. And then so now you have a core architecture here. This is the monitoring system that we were looking at. This is how our Prometheus will work. Okay, so you have your applications here, or your servers, or any data source here. So I will not go into details now. You know now what is the data source here. So these are emitting the metrics here, just like how your vehicle will emit smoke. This will be emitting the metrics here. So this where you will be collecting those details here. So in Prometheus you will be installing something called node exporter. Okay, if you are into Linux, you will put that particular module so that you will get that particular parameters. Okay, once you collect those, okay, so once you have these agents installed, this will be sending the details to your database here. So this database, it will be collecting all the details here. Okay, so now you are querying the data here and you are aggregating, means you are just separating this layer here. Okay, so now there are you have an alerting engine. So based on that evaluation, it will send the notification or it will send the tickets here. Okay, so now here you will have a visualization dashboard where Prometheus will not do this. Okay, it will give that details to your Grafana. Okay, where you will be seeing all your dashboards here. Okay, so you will be visualizing everything here. So these are the core architecture components here. Okay, so your collector agents, okay, you will be collecting all the applications data, everything, it will be forwarding it. Then once it is forwarded, you will store all these metrics here. Okay, then you will have that querying layer which will aggregate the data, which will filter it. Then you will have something called alerting engine, where if your alerting is triggered, okay, if something is kept at the threshold level, then it will send the notification when the thresholds are breached here. Okay, now you are getting a 100% utilization for 6 minutes. Okay, so your alert has breached now. Now it will generate a ticket like the CPU utilization is high. That's it. Okay. So where the visualization dashboard is for us to see it, okay, how the CPU or server looks like. Okay. So Grafana will be pulling it from that particular Prometheus database, okay, or whatever it is capturing that data, it will capture it and it will visualize it onto the servers here. You can see it how the network is performing, what is the CPU utilization, everything you can see it in the dashboard. This is for our human readable or human consumption. So now I will take a little break. Okay. After that I will come. Okay, I will. So now what are the metrics that you want to collect it? Okay. What are the metrics type where you want to collect the data here? Okay. So which will be used here? What are the counters here? Okay. So how your website is, let's say we'll take an example. Okay. So you are getting lot of request, like website, web page is getting lot of hits, like people are getting login here. Okay. So now you will be taking that particular usage. Okay. So how many users are coming in and how many users are logging out? Okay, incoming and outgoing. Okay, so this is to track the engagement. Okay, how the user is being engaged with the website. Okay, then your CPU utilization, how the CPU is being utilized here. Okay, so based on the CPU, memory, and then queue size is your queue depth. Queue depth is like your storage. Okay, so I will ask this in interview questions if they are coming for level 3. Okay, level 3 or more than 10 years of experience. If they come for an interview for support, I will ask, okay, how will you check the storage capacity? Okay, what is the parameter that you will check for the storage? So I have good CPU, I have good memory, and how are you going to check on the on the storage end? Okay. So if he has worked on the what is that? Realistically, if he has worked, then he will answer this: what is the queue size or queue length? Okay. So you are just beginners. I don't feel like you will get these type of questions. This is a support L3 level question. Okay. If you want to know, I will explain it. I will take this example. Let me copy it here. I will take it to this. Okay. So you have queue length here. Okay. So you have a disk here. Let's say. So disk will work on the input output per second. Okay, IOPS, we call it as IOPS. So this is your disk. Okay. So these are the VMs here. So you attached this disk on to multiple VMs or multiple instance. Okay. So VM1 is also writing, VM2 is also writing, VM3 is also writing, VM4 is also writing. Okay. So whenever VM1 writes on the disk, okay, all the other VM2, VM3 and VM4 has to wait until this VM1 is done with its operations. Whether it is writing the content or reading it, it will lock it for some milliseconds. So this length, whatever they are waiting, this will be queued. This is called queue length. The more queue length high, okay, if it is high, then your storage is overloaded. If the queue length is less, okay, then the storage is utilized properly. So this is the simple question for level 3 guy, okay, who is having more than 5 years of experience, not below 5. So that will be the question for a 5 years guy. Okay. So now you have queue size. What is the queue size here? Then based on that, you will be generating the ticket here. Like your queue length is high, maybe your storage is being impacted here. Okay. So then on the distribution of values, okay, how you are going to distribute it. Okay. So how much it is being utilized. Okay. So what is the latency to reach? Okay, it will be calculated based on the percentage. Okay, how much time it is able to reach that HTTP request. Okay, if you are getting high, then your performance is getting low here. Okay, so these are all the parameters that you will be using it for the monitoring here. Okay, so you have latency here. Latency we have already discussed in the networking terminology. It is time to reach or how long it will take to respond. Okay, that is your latency. It should be, you should have very good latency. That is why whenever whatever close region you have, you should be picking up that particular region so that you will have a low latency. So low latency means you can reach it easily. Okay, if you are taking up North Virginia or Canada, you will have a high latency. Okay, even if you are taking any Asia Pacific also, you will have a good latency. Okay. So then you have traffic. Okay, how much requests are coming in per second. Okay, what is the throughput here? Throughput means incoming and outgoing. That we call it as throughput. Means this is the bandwidth. Okay. Then how many concurrent users or sessions are being happening here? So how many users are directly coming and connected? Okay. Then errors. How many errors you are getting? Any 403, 404 errors or 500 errors like internal error. All that you will be capturing this. Okay. Then your saturation point. Okay. So how much CPU is utilized completely? Okay, what is your memory utilization? What is your disk I/O or your queue depth? This is what I was just explaining you. So you will have a disk I/O there. Okay. So then what is the business requirement? Okay. Let's say if someone orders it, if you are working on any FMCG or fashion designing. So let's say if someone orders it, that needs to be tracked. Manually it has to be tracked whether the tracking is happening by the logistic vendor or not. Whether the customer is happy with the delivery. How that product is happening. How that product is reaching to the customer. This is not a technical requirement. Okay. This is a business requirement. Okay. So then there will be other metrics. Okay, so if there is any connection, lot of connections are happening, whether there is any external dependency, like you are connecting to any external APIs, all that you will be monitoring it. Okay, so what metrics you are going to collect and what you will be collecting it. Okay, at the host level. Okay, so let me take this. I don't have a diagram here. I will take this one and I will explain it. So this is your host level. Okay, let's say this is your computer. Okay, host level. This is either it can be physical or it can be virtual. Okay, then you are hosting the application here. I will put this an application. Okay, this is an app. So this is running on this server. Okay, let's say this is a 2 vCPU and 12 GB RAM. Okay, and 1 TB hard disk. So there are lot of other services also, applications also. This is app 1. Okay, now you have users here. So users, okay, they are connecting. This app is connected to the external APIs, okay, like weather, finance, forecasting, all that it has connected this API here. This is how it is running. Okay, so now I am getting this is connected to a database also. And this is behind a load balancer. Okay, and this is connected again to a network here. I will make this diagram here. Okay, this is a network. Okay, so I will be monitoring on every aspect here. Okay, let's say I will be monitoring at the host level or VM level all these metrics here, CPU, memory, disk, everything I will be monitoring here. Okay. Let me take this. Okay, so I will be monitoring here disk here, CPU and the memory and services. Whatever services are required to run this. Okay, let's say this is on the Oracle DB. Okay, this should be running, and the APIs also it should be connected. These are the external APIs. Okay, and you should be having keys for that. Okay, so then you will be checking the network also. Network should be up and running. Okay, and it is behind the load balancer here. Okay, so the load balancer should also be working. Okay, and whatever he is trying to connect, I should be checking the latency also. Okay, I should be checking the latency. Okay, whether these are reachable or not. Okay, now I have connected here for this two cloud services I have connected. Okay, this is one cloud AWS and this is a GCP. Okay, I have analytics service here. I have APIs here. Okay, I have analytics in Google. So I will be monitoring this also, the cloud services, and then I will be checking this and I will be checking the latency. All these I need to be monitoring it here. If something goes wrong, I need to get an alert here. Okay, I need to see this application. Okay, what is the consumption of the application? How many requests are coming in? what is the uptime and queue length. Okay, so whether this service is stopped or not. If the application service which I am running, let's say I am running it app1.exe on Windows, okay, or app.py on my Linux, okay, this stopped running, or this is dependent on any service, okay. Let's say this is on the firewall, let's say firewall service, it is blocked here. So I am running it on Linux and firewall port is blocking on this particular application. Like let's say this is running on 2185. So someone blocked it on this port inside the firewall. Okay. So now the application will not be accessible for him. Okay, because he has blocked the port here. So all this I have to be monitoring it here, whether this is up and running. My ultimate goal should be this app should be running. Okay, if this is impacted, I will lose my business. Okay, that is where I will be configuring all these metrics here. Okay, so I should be collecting these metrics and I should be monitoring all that: CPU, memory, disk IO, network statistic, and the load average. Okay, so if you are into I will now go to the Linux on what knowledge you have collected. Okay, so I will be checking this CPU usage. Okay, what is the CPU usage you are going to collect with the command? Okay, so you will be using the time command here, where you will get the CPU, or you will be using top command. So this it will be done by your Prometheus or your monitoring tool. So you don't have to capture it. It will be built in. It will capture it using that shell scripting, all that. The tool will be able to help you. So you are not writing anything. Okay. So now it is checking the with free command. Okay. If you type free on your Linux, it will show what is the disk utilization. Then df-h. Okay, and the disk IO also. Okay, then your network statistics. This you will check with netstat. Okay, then load. Okay, you will be using the top command. So all these are all monitored by your monitoring tool. You are not going to do it manually. It will just pull that information from the OS using those scripts. Okay. Now you have a application metrics here. Okay. So what are the request rate? What is the error you are getting? What is the response? All that you will be tracking at the application level. So this also done by your monitoring tool. So you will not touch anything or you will not configure anything here. This will automatically capture that particular application metrics. Okay. So now these are the infrastructure dependency. Okay. So whether your network devices are up and running. Okay. So you are running on containers. Okay. On your Docker, or you are running it on Podman. Okay. So it will be checking those containers also. Or are you running it on a VMs? It will check. Okay, whether your database is up and running. Okay, or have you connected to any external cloud services? Like you have Google or AWS, all that. From the infrastructure perspective, I will be collecting it. Or are you connected to any load balancer? Okay. So any third party API Okay, are you using it? Are you using any latency here? You have Cloudflare. Okay, before opening your website, Cloudflare will check whether you are a bot or a human. Okay, so do you have anything external dependency? So all that I am going to collect this information. This is just to monitor the health of my services. Okay, so now you have two essential methods here. Okay, so you have a red method here. So for every services, so you will be monitoring it rate. Okay, what are the requests that you are getting it per second here? So what are the error rate? Okay, so any internal error, like you have any server error, so internally I am getting any error and I am not able to give it to the user here. Okay, then your latency distribution. Okay, is it 50% or 95, 99, all that. Okay, so then you will be using this use method, that is the red method. This is the for resources. What is the utilization here? What is your saturation point? Okay, so beyond this, if I am waiting, then the user will be impacted. User will not stay for this much time. Okay, so you will define it. Okay, what are the error rates here, error counts? So you are getting lot of packet drops. Like if you are doing a ping here, how many packets are getting dropped here? So what are the IO errors you are getting it on the disk level? Okay, so you are getting lot of utilization on the disk. That is why there are lot of errors you are seeing. Okay, this is your use method. This is for resources. Red method, this is for services. Okay, that you will be checking for these two essential monitoring methods. No matter what service you are running, so you will see these. What is this? In generic terms, you call this one as a thumb rule. Okay. So you run it any service, this will be your thumb rule for that particular service, and for resources, this will be your thumb rule. No matter you go for a physical CPU or physical server or virtual server or a container, whatever you go. Okay, or a disk or network, anything, if it is resource, then you will be checking these three parameters. If it is service, you will check these three parameters. Okay, that's how your monitoring will be. Now you have something called push and pull. So I am not talking about now here about physics here, which will be easier. Is it pull or push? So I got this question in my SSLC when I was writing exam. I got which one is easier? Why it is easier to pull than push? Something like that. Okay, this is not a physics. This is like one method is I will just pull that information and I will keep it. That's it. Push is like I am going to take this and I will send it to some place. So that is the difference between pull and push methodology. Okay, pull is like you are just collecting the data. Okay, so it will check whether the target is down or not. Okay, generic example, let me tell you. Okay, so pull method is like you will throw garbage, right? Every day you throw garbage, that BBMP vehicle will come and they will collect the garbage here. Pull method is you just collect, you just dump the garbage and keep that aside. That's it. Push is like you will take that and you will uh, send it to that particular vehicle, or you will give it to that person who is collecting that garbage. Okay. So I have made one diagram for this. Okay. Let me go to this diagram, pull and push. So after this we will be done, so that you can take a little break also. So this will be the last. Okay. So then we will continue the other session tomorrow also on the same topic. Okay. So this is the Prometheus, okay, where this is a pull method. So you have push here. So this is for centralized monitoring server. I have lot of physical infrastructure where I need to continuously monitor this. Okay. So this will be suitable for, I will just collect the data here. Okay. And I will be storing that into one particular matrix, or I will store this information. Okay. So what I am going to do, I will discover all the services, how many VMs I have, how many servers I have, okay, what are all the models I have, everything I will be doing it. Okay. So in pull method, okay, the data originates, it will be seeing the where the data originates, and the exporters, you will have exporters here. Okay. So it will be pulling that information via your node exporter. So here it will be, you will be installing node exporter, or if you want to export any databases, you will put those plugins here. So then it will be pulling the data here to one location. That's it. So it will see, okay, if the target is down, okay, I will know. Okay. Whether the endpoint is reachable, I will come to know. Okay. So it will be checking on the endpoints here. Okay. How often I have to check, what I have to see. Okay. Everything it will be collecting here. So here push based is, I will see, okay, if let's say you are running a Lambda function here. Okay. So I will just monitor if the Lambda function is executed correctly or not. That's it. If it is executed, I will send this message, okay, this has been executed. That's it. Okay. So this is for short term, you will be using this push method. Okay. So where you will be reducing the latency here. Okay. So this can lose the metrics, okay, if you are not able to capture this collector service. Okay. If the data is not collected, so you have a service running for this, it will capture it. If it is not able to capture, then there is no surety like whether it has successfully run or it has failed to run. Okay. So that is the difference between pull and push methodology. Okay. So pull, it will just pull the information and store it. That's it. If you want to visualize, you put the plugins and you take it to the other tool called Grafana, where you can see. My job is just to see it whether these are working or not. That's it. That is the overview of your pull based pattern. Okay. Now you have something called SLI, SLO, SLA, So we will be talking about, if you are into support, majorly it will be talking on the SLA, where you will have a penalties here. Let's say if you are not providing the SLA, you will be penalized for this. Okay. So let's say if my server is down, you should be responding that server within 15 minutes. You need to acknowledge it and you have to work on this server. Okay. If you are not working, then I will give you a penalty here. Whatever I have to pay, I will reduce that payment. That is the service level agreement. Okay. So let's say you have made a service level agreement, like let's say I will take one example here. Okay. So I have an SLA. Let's say this is my critical service. Okay. So this should be 99.9% up in complete year. Okay. So if this server is impacted by 98%, okay, only 98% is up. Means let's say this has rebooted 5 times in 1 year. So 1 year it has rebooted 5 times and the uptime of this is impacted like 98%. Then I will put a penalty on this. So I will not pay for this monitoring, you need to pay me back. Because if this service goes down, my business will be impacted. Okay. This is where your SLA will come. SLA will be very critical. Okay. So now you have something called service level indicator. Okay. Where you will be measuring the quantitative aspect of the service. So how that service is responding. Okay. So this is your indicator and this is your objective. Okay. So what is your internal reliability on that particular service? How much you can rely on that particular service. Okay. So these are all the 3 aspects in the monitoring here. Okay. Where SLA will be treated very critical here. Okay. So these are all your parameters for the monitoring. Okay. So there are a lot of other monitoring tools also. Let's say you have severity here. If you have worked on it, then you will come to know what is the severity here, P1, P2, P3. Okay. There is no P0 here. It will be critical here. If you have P1 issues, then everyone will be on their toes and everyone will be wake up and they will be running and they will be working on this priority one. Okay. All the rest of the services or tickets that will not be much impacted. So based on the severity also you will get the appreciation also from the customer. Okay. If there is any priority 1 tickets, then everyone will be on the call and they will be working. Okay. So and you will be having a SLAs for that particular P1 ticket. So if there is a P1 ticket, you should close that issue within 4 hours. So that you will have agreement with the customer. Okay. So we'll see tomorrow what are all these tools tool stack, all that. Then we will come to cloud. So in the evening class, we will see that with respect to cloud, what are all the monitoring tools that we have in the cloud, how we will do the monitoring. Okay. That's it for today. We'll connect back in the evening.